Okay, so this is the second of our two videos on trigonometric limits. So in this video we're going to take that sine x over x result that we got in the previous video, and we're going to show how to use that to tackle a few more results. Okay, so just as a reminder, let's put it up here at the top. The limit as x goes to 0 of sine x over x is equal to 1. Okay. And there's a pretty tricky geometric argument to establish this result. This is pretty much the hardest limit that we deal with. Coming up with that limit is pretty much the hardest thing that we do in the entire limits chapter. But now that we have it, we can do a few more things. So let's say I want to take care of this limit here. We're going to need these two limits, by the way, the one we already have and this one. We're going to need these when we compute the derivatives of the sine and the cosine functions. How do I deal with this limit? Well, one thing I can do is I can make use of some common identities that I'm familiar with. So there's going to be a bit of playing around here. So what I'm going to do is I'm going to take my original function, 1 minus cos x over x, and now this is, it's going to seem like it comes out of the blue, but it's not really coming totally out of the blue. This is the sort of thing that comes with a bit of practice and experience with these sorts of things. One of the tricks that you can often do when you're stuck in an expression involving trig functions is, well, you've got 1 minus cos. You don't know what to do with 1 minus cos, but you do know what to do with 1 minus cos squared, because we know that 1 minus cos squared x is sine x, or sine squared x. And if we get things involving sine, that's good, because we know a limit involving sine. So why am I multiplying by 1 plus cos? Well, if I multiply by 1 plus cos, I get a difference of squares. 1 minus cos x times 1 plus cos x. That's going to give me exactly what I want. It's going to give me 1 minus cos squared x up top. It's going to be x times 1 plus cos x on the bottom. And now I can say that I've got, so 1 minus cos squared, sine squared plus cos squared is 1, so that's just sine squared x. Okay, and now what I'm going to do is sine squared is sine x times sine x, right? So I'm going to break that apart into two pieces. I'm going to take one of those sine x's, and I'm going to group it with that x you see on the bottom. And I'm going to take the other one, and I'm going to put it with everything else, the 1 plus cos x. Okay, and well, now I've got a limit of a product. I know what to do with the limit of a product. I take the product of the limits, and I know what this first limit is, right? Limit of sine x over x, we've got it up here. It's 1. So it's 1 is the first limit. The second limit, well, I also know that as x goes to 0, I know that sine x goes to 0. So I know that limit is 0. And I also know that when x goes to 0, cos x goes to 1. So I've got 0 over 1 plus 1, 0 over 2, that's just 0. 1 times 0, still 0. And we've done our job. Okay, so we won't make too much use of this result in the limits chapter, but we will definitely need this once we get to derivatives. Let's move on to a couple of the sorts of limits you might see when you're doing the exercises in section 1.3 or in the online homework. Here are a couple of limits that we might want to deal with. This first one, there's two ways to tackle it. I'm going to show you two ways to deal with this. By the way, there's a wrong way to do it. Some of you might be tempted. I know some of you are probably tempted. You see this too and you think, hey, well, I know, because I just told you. I just said that the limit as x goes to 0 of sine x over x, I know that this limit is 1. And you say, hey, let's just bring the 2 out, and then I'm going to have sine x over x. Yeah, that would be great if you were allowed to do it, but you're not. Sine, I can't pull things out of the sine function. The sine function doesn't work that way. There is an identity that applies, though. We could write this as, so sine 2x, it turns out that sine 2x can be written, and again, this is a standard trig identity. In fact, it's one of the ones I gave you in the review videos. Sine 2x can be written as 2 sine x times cos x. So I could write it like that, and then of course I do see that, oh, here's my sine x over x, so I can group that together. And then I've got, if I play around with the limit laws, I've got a constant times a limit that I know times another limit that I know. I've got 2 times 1 times 1, and I get 2. All right, that does the job. Another way you could do it is you could also do it like this. You could say, so let's kind of set that aside, and we could say, well, instead, you know what we could do? I could do this. I could say that's the limit as x goes to 0. I'm going to do this. So, well, maybe let's back things up a bit. The other thing I could do is I could say, you know what, this result here is going to be valid for really, you know, as long as I've got something that goes to 0, right? If I had like sine y over y, as long as y is going to 0, this is still going to work out. And so one of the things I could do is I could say, well, you know, if x is going to 0, 2x is also going to 0. And you say, well, hey, if I had a 2x on the bottom, then, you know, these match. Those are now the same thing. And so I'd say, yeah, this limit, for the same kind of reasoning as this limit up here, it should also be equal to 1. But I can't just throw a 2 on the bottom. That's cheating. I can't divide by 2. If I divide by 2, I change the function. So what do I have to do if I divide by 2? I need to also multiply by 2, right? Then those 2's cancel out, and I can go ahead. But of course, this 2 is a constant. I can pull it out of the limit, and I could write this as 2 times the limit as x goes to 0 of sine 2x over 2x. And then I can say, okay, now I know that this limit is 1, so I get 2 times 1. And again, by different means, I get that the limit is 2. Let's end with this one. This one's a little bit trickier, sine 3x over sine 5x. Let me show you how this works. We play a couple of games here. It's going to be the same sort of trick as what we just did, but I'm going to split things up. Sine 3x. To be determined denominator. Sine 5x. By the way, I should mention that, you know, if 1 over 1 is still 1, and so as you might expect, if I did x over sine x, if I take the reciprocal, I still get 1 in the limit. Flipping it over, you know, if I flip 1, I still have 1. Okay, so now I say, well, you know, if I had a 3x here, I'd be okay, but let's start off. I'm going to put an x here, but I can't just put an x here. If I put an x there, I've got to cancel it. So let's put one up top that cancels that x. Those x's cancel out, so I haven't changed anything. But then, as I mentioned, I really don't want just x there. If I've got a 3x up top, I need a 3x on the bottom. Okay, well, I can't put a 3 unless I have something to cancel it, so let's put a 3 right there. Similarly here, I want to match that 5x in the sine function, so if I put 5x up there, that's going to match up. I'm going to get a limit that comes out to be 1. But if I put a 5 on the top, I need a 5 to cancel it. Let's put it right there. Well, that's good. Now I've got a constant. Constant comes out, and I've got 2 limits left over that are both equal to 1. So what's my limit? It's 3 over 5. Okay, that's all we'll say about trig limits here. We'll do more examples in class.